Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
Did you know that there are substances that aren't really acids, but they're acidic? Or there are substances that really aren't bases, but they're bases? Well, I guess if they're acidic, they're acids, and if they're basic, they're bases. But what we want to talk today is about a fancy term called salt hydrolysis. Now, what's a salt? Salt is an ionic compound. So some ionic compounds are acidic and or basic. Huh? Remember the difference between a strong acid and a weak acid? Strong acids completely dissociate, and weak acids only partially dissociate, and it all comes back to how strong the bonds are. So let's take a classic example of something just of sodium fluoride. Now, sodium fluoride, if you think about it, there's also a weak acid called HF, hydrofluoric acid. And if we were to break it apart, right, partially break it apart into hydrogens and Fs, only a portion, maybe 5%, even 1% of these break up. And so if I take sodium fluoride, here's the crazy thing, and I put it in water, it'll be a base. Let me prove it to you. Now, first of all, sodium fluoride is something that completely dissociates in water because all sodium compounds break into water. So frankly, I don't care about the sodium, because this would break apart, let's go ahead and write it out, to Na positive and F negatives. But it's the F negative that does something interesting, because if I took F negative and I put it in water, now notice I don't write it with H2O, but HOH. You see, because the bond between H and F is pretty strong, this H is going to get together with this F. Now, not completely, so we draw a double arrow, and it makes HF. See, this H comes and attaches it to the F, because they like each other, strong bond, but what's left over? Hydroxide. Well, hydroxide is what makes bases, so that's what makes this a base. So a salt, get care of this, the salt of a weak acid, the weak acid, his salt, is a base. The salt of a weak acid is a base. We could do another one. Let's do another one, in fact. Let's say that I have a chemical, which I have, let's just write over here, we've got sodium carbonate. All right. Now, the acid that goes with carbonate is carbonic acid. This is what you find in a can of soda. All right. So the salt of a weak acid is a base. So I don't care about the sodium, so I write carbonate. And I react with water. Don't write it as H2O, but HOH. And that's going to make what? Now the H is going to connect with the CO3, and it's going to make H2CO3 plus OH minus. I think we have to put a 2 here and a 2 here to make that work. Now, that's for the salt of a weak acid is a base. The salt of a weak base is an acid. So the opposite is true. Let's do that. So the classic weak base in the world is ammonia. Now, what would be the salt of ammonia? This one's a little bit confusing. It would be something like ammonium chloride. These guys are related. So if this is the salt of the weak base, I'm going to write NH4 positive. Now this one's a little bit weird because what it doesn't do is it doesn't really react with water. It just breaks apart into H's plus NH3. Because he doesn't like to live like that, because ammonia, right? Ammonia likes to stick together, right? Again, the weak base reaction for ammonia, I'll put it here, NH3 plus HOH makes ammonium plus hydroxide. You see, because it would rather be NH3 than NH4 positive, so that drives this reaction over into this space right here. Let me just sort of say one more thing, because maybe I haven't completely been honest with you. We always say that we make this H positive right here, right? Because that's actually not exactly true. You don't have like a simple little H positive. You actually make something a little bit more complex, and this might explain. If I were to write this actually in complete accurate terms, you'd say NH4 positive plus water. Now I'm going to write this H2O here. It actually then makes NH3, right? We talked about that, plus this thing called H3O positive. And that's called hydronium. And that's actually the part of an acid that makes an acid an acid. We simplify, us chemists simplify and say H positive is what makes an acid, but what's really happening is the H is connecting, this is the water molecule, is he connects onto a bonding site, and then he has a positive 1 charge, and that is the hydronium ion. There's actually a couple electrons here too. And that's the actual thing, but when we do all of our math and all the stuff that we talk about, this right here is simplified to this because it makes sort of the math and the equations a lot easier. But that's actually the most accurate way to do this. And if we were to do this with the HF, we'd actually say HF plus water, and it makes H3O positive plus F negative. This is the acid piece. But it's the math and all the stuff we do, this equation and this equation, this is a lot easier to write. And that's called the hydronium ion. So yes, strange things that salts, yes, salts can be acid. Here's this, the salt of a weak acid is a base. The salt of a weak base is an acid. We'll see you in class.